Hi, I'm Matt Diedrich, and I'll be presenting the bridge pattern. The bridge pattern is a structural design pattern. The bridge design pattern allows you to separate the abstraction, i.e. the client-facing interface, from the implementation so that they can vary independently. This means that the abstraction can exist in one class hierarchy and the implementation at another, and the abstraction interface maintains a reference to the implementation interface to carry out functionality specific to the abstraction subclass. Motivation. The bridge pattern is useful when both the class and what it does vary often. The class itself can be thought of as the abstraction, and what the class can do as the implementation. When an abstraction can have one of several possible implementations, the useful way to accommodate them is to use inheritance. This approach isn't always flexible enough, as inheritance binds an implementation to the abstraction permanently, which makes it difficult to modify, extend, and reuse abstractions and implementations independently. The bridge pattern allows the abstraction and the implementation to be developed independently, and the client code can access only the abstraction part without being concerned about the implementation part. Consequences. An implementation is not bound permanently to an interface. The implementation of an abstraction can be configured at runtime. It's even possible for an object to change its implementation at runtime. Improved extensibility, because you can extend the abstraction and implementation hierarchies independently. It also shields clients from implementation details, and implementation classes can be reused in multiple places. Known uses. The bridge pattern is especially useful when dealing with cross-platform apps, supporting multiple types of database servers, or working with several API providers of a certain kind. Graphical user interface frameworks use the bridge pattern to separate abstractions from platform-specific details. For example, a GUI framework separates a window abstraction from a window implementation for Linux, Mac, using the bridge pattern. This means that there can be one client-facing interface and several implementations for each platform, such as Mac, Windows, or Linux. And you can identify the bridge pattern by distinctions between some controlling entity and several different platforms that rely on it. The structure of the bridge pattern. We have the abstraction, which is the core of the bridge design pattern and defines the client interface and contains a reference to an implementer. The refined abstraction implements the abstraction interface using the implementer reference. Implementer defines the interface for implementation classes. This interface does not need to correspond directly to an abstraction interface and can be very different. A concrete implementation implements the above implementer by providing a concrete implementation. And here we have a simple example. The abstraction in this example is the shape abstraction and contains an abstract draw method and a reference to a draw API implementer interface. A refined abstraction here is the circle class, and it represents the concrete abstraction and implements the draw method using a reference to the draw API. The implementer is the draw API interface, and it contains a abstract draw circle method, and the concrete implementations are the red circle and green circle, which implement the draw circle method. And for my example, I use our term project, which is going to be reading addresses. The address reader defines the client-facing interface and holds a reference to an implementer interface, which here is the address file reader. And we have a refined abstraction which reads in addresses and validates them. It implements the abstraction interface and receives a reference to an implementer object at runtime. This class uses the implementer to read in the addresses without worrying about details of how it is done. And here it could take any of different kind of implementers, so it could read in addresses from CSV files, Excel files, or databases. And here's the iAddress file reader implementer interface, and it defines the implementer interface that the abstraction can use to read in addresses. The concrete implementers then implement this interface to read in addresses in a specific way. The concrete implementer example here is a CSV file reader which reads in addresses from CSV files. And it implements the interface with logic to read addresses from a CSV file. Other implementer classes could read in addresses from Excel files or even from a database. And here would be the client, and it creates a valid address reader, and it passes in a specific implementer, concrete implementer, and it reads the addresses, validates them, and prints them to the console. And here we have the UML layout of the abstract and the abstraction and the implementer and their concrete examples. And here's the references I use, and that's it.